This little puck fires 300,000 laser points every second, can see in complete darkness, can measure down to the centimeter, and is going to be the eyes of my cave mapping platform. There are tons of LiDAR sensors on the market, so why did I choose the VLP-16? First, availability and cost. VLP-16 has been in production since 2014. The autonomous vehicle industry went through thousands of these sensors during development and testing. Now, a lot of these companies have moved on to newer sensors, upgraded their fleets, or in some cases, shut down entirely. That means used VLP-16s show up on the secondary market all of the time. I paid $321 for mine. The second reason I chose the VLP-16 is the ecosystem and support. The VLP-16 has mature, battle-tested ROS and ROS2 drivers. The Velodyne driver package has been around for years. When you're trying to debug your SLAM algorithms and your map is drifting or your loop closures are failing, the last thing you want to do is also be questioning whether your sensor's driver is giving you good data. There's also just a ton of community knowledge out there. Whatever problem you hit, someone has probably had that problem in the past and already written about it. Third, durability. This thing is designed to be mounted on top of vehicles driving all around San Francisco. Rain, fog, thunderstorms, vibration. The build quality is pretty impressive. IP67 rated, operating temperature from around 10 to 60 degrees Celsius. For field work in caves where you might encounter humidity, huge temperature changes, the occasional bump against a rock wall, that durability matters. Now, I'll be honest, if I were starting from scratch or had an unlimited budget, I'd probably choose a different sensor, but LiVox sensors like the Mid 360 offer incredible point density per dollar. They use a non-repetitive scan pattern that fills in over time, which actually works really well for SLAM applications. Downside, the scan pattern can be a bit tricky to work with, and they're a lot more expensive. Ouster sensors like the OS1 give you more vertical channels, up to 128, and higher resolution. Plus, they output camera-like images alongside the point cloud, but they're way more expensive and draw a bit more power. Budget options, like the RP LiDAR series, can be had for a few $100. And for simple 2D mapping, they're great. But for full 3D coverage in complex environments, you're limited. For this specific project, the VLP-16 hits the sweet spot of capability, cost, ecosystem support, and build quality.